Summary of LangChain Experimental Autonomous Agents Autogpt Output Parser Autogpt Output Parser NaN. The autogpt output parser is a class employed by autogpt to interpret the output generated by a large language model LLM. Its primary function is to extract valuable insights from the LLM's response, such as tasks that need to be completed, thoughts or ideas generated, and the reasoning behind the LLM's response. The parser employs a combination of regular expressions and language models to comprehend the context and structure of the LLM's output effectively. For instance, if an LLM is asked to write a blog post about a particular topic, the autogpt output parser might extract the key topics, potential headings, and a summary of the main points from the LLM's generated text. This parsed information can then be used by the autogpt agent to take appropriate actions, such as refining the blog post, searching for relevant information, or generating further content. Component 1. The autogpt output parser class leverages a combination of regular expressions and language models to process the LLM's response. Regular expressions are used to identify specific patterns in the text, such as keywords, phrases, or formatting, while language models are used to interpret the meaning of the text and extract the relevant information. For example, the parser might use a regular expression to identify all the tasks mentioned in the LLM's response, and then use a language model to understand the context of those tasks and determine the appropriate action to take. Component 2. It utilizes a specialized function named parse thoughts to detect and extract thoughts from the LLM's response. This function uses natural language processing (NLP) techniques to analyze the LLM's output and identify sections that contain thoughts or opinions. For example, if the LLM is asked to generate ideas for a new product, the parse thoughts function might extract sentences like a new product could be a smart home assistant or the product could be designed to help people with their daily tasks. These extracted thoughts can then be used by the autogpt agent to generate further ideas, refine the product concept, or perform other actions. The autogpt output parser exists as a class within the autogpt framework. It plays a crucial role in connecting the LLM's output with the internal logic of the agent. It acts as a translator, transforming the LLM's response into structured data that the agent can readily understand and utilize for its subsequent actions. This structured data can then be used by the agent to make decisions, take actions, and ultimately achieve its goals. Imagine a scenario where autogpt is tasked with researching a specific topic. After the LLM provides a list of relevant sources, the autogpt output parser transforms this list into a structured format, including URLs, titles, and brief summaries. The agent can then use this structured information to efficiently access and analyze the sources, contributing to its overall research process. The autogpt output parser plays a critical role in autogpt by enabling the seamless integration of outputs from LLMs into the agent's decision-making process. It serves as a mediator, converting unstructured LLM responses into actionable instructions for the agent. This conversion allows the agent to understand and respond to the LLM's output effectively, leading to more efficient and goal-oriented actions. For instance, if the agent is tasked with writing a product description, the LLM might generate a lengthy and unstructured text. The autogpt output parser would then extract relevant information, such as product features, benefits, and target audience, and present it to the agent in a structured format. This structured information allows the agent to refine the product description, generate marketing materials, or perform other actions related to the product. Enhanced output understanding. The autogpt output parser effectively extracts meaningful information from the LLM's output, enabling efficient decision-making. By transforming the LLM's often unstructured responses into structured data, the parser facilitates a more comprehensive understanding of the LLM's output. This, in turn, enables the autogpt agent to make more informed decisions, leading to more effective actions and ultimately achieving its goals. For example, if the agent is asked to summarize a lengthy research paper, the parser can extract key findings, conclusions, and supporting evidence from the LLM's output. This allows the agent to effectively summarize the paper and present its findings in a concise and coherent manner. Improved agent efficiency. The structured output from the parser streamlines the agent's workflow, enabling it to process information more quickly and efficiently. By providing the agent with structured data, the parser eliminates the need for the agent to manually parse and interpret the LLM's output, significantly improving its efficiency. For instance, if the agent is tasked with scheduling meetings, the parser can extract meeting times, attendees, and locations from the LLM's output and automatically create calendar events. This streamlined workflow allows the agent to efficiently manage its schedule and focus on other tasks. Handling ambiguous responses. The parser may face challenges when interpreting ambiguous or unclear LLM outputs. LLMs, despite their advanced capabilities, can sometimes produce responses that are difficult to interpret. For instance, the LLM might provide a response that is incomplete, contradictory, or irrelevant to the given task. In these cases, the parser might struggle to extract meaningful information or provide accurate guidance to the agent. Adapting to diverse LLM outputs. The parser needs to be adaptable enough to handle the diverse styles and formats of responses from various LLMs. LLMs are developed by different organizations and may employ different techniques and approaches for generating text. This can result in responses with varying styles, formats, and levels of complexity. The parser must be able to adapt to these variations and extract relevant information from a wide range of LLM outputs. This challenge is particularly important considering the ongoing development of new and more sophisticated LLMs, which will likely introduce even more diverse output styles.